July students, yesterday we did a graphical problem of linear programming. Today we are going to do it graphically also, but we have to formulate the equation of the graph. As I have already told you that linear programming can be solved by graphical, and other section of the linear programming is to first of all we are having a question in the statement form. We have to formulate it in mathematical formation. So that is the graphical formation. So students, the problem says question number 4 of exercise 12.2. Exercise 12.2, question number 4. Look at the question number 4, please. A manufacturer produce nuts and bolt. And a manufacturer produce nuts and bolt. It takes 1 hour of work on machine A and 3 hours on machine B to produce a package of nuts. To produce a package of nuts, manufacturer use 2 machines, A and B. It takes 3 hours on machine A and 1 hour on machine B to produce a package of bolt. This is the bolt, another item that he wants to produce. He earns a profit of rupees 17.50 paisa per package on nuts and rupees 7 per package on bolt. So this is his profit. Question says how many packages of nuts and bolt should be produced each day so as to maximize his profit. He wants to know the maximum value, maximum profit. So how much of nuts and how many of bolts he should produce if he operates his machines, both the machines, for the at most 12 hours a day. 12 hours a day he can use his machines A and B. At most 12 hours. At most 12 hours. At most 12 hours is at the most, means maximum he can use the machines for 12 hours. That means at the most, students, at most means something less than 12 hours. At most means at the most. You should now you should try to understand it. At most means the maximum he can use the machines for 12 hours. So students, we have to formulate this statement form of equation in graphical way. So I will try to formulate it in mathematical form. So we start formulating this statement on graphical way. In graphical way, say our question is this: how many package of nuts and bolt should he be produced each day? This is our question. This is our question. So first of all, we suppose that manufacturer produce X number of nuts and Y numbers of bolt. That will be our supposition. Let manufacturer produce X number of package of nuts, produce nuts and bolt, X number of package of nuts and Y number of packages, I should say packages here, okay, packages of bolts. This is our supposition. Now we have to formulate it in graphical way. I would like to formulate it in a table so that you can understand it better way. So student, we formulate this statement form in graphical form. So we have to reduce this information in this table. So here our question is, how many package of nuts and bolt should be produced on each day so as to maximize his profit? I will write down package of nuts. Package of nuts, bolts, and we have to use two machines. Machine A and machine B. Machine A in hours, machine B in hours, and our objective function is the maximum profit. What? Profit, maximize his profit. How many package of nuts and bolts should be produced each day so as to maximize his profit? Profit. This is the other column. So machine A works for few hours, machine B works for few hours. So we have to take the nuts information. It takes 1 hour of work on machine A and 3 hours on machine B to produce a package of nuts. So this information of the nuts I have to put it here in the table. It says that 1 hour of work on machine A, that means 1 hour on machine A, and 3 hours on machine B, that means 3 hours on machine B to produce a package of nuts. And the bolt, for the bolt, it takes 3 hours on machine A and 1 hour on machine B to produce a package of bolt. So for making bolt, I have to use both the machine A and machine B. 3 hours on machine A and 1 hour on machine B to produce a packet of bolt. That means I have to write it down 3 hours on machine A. This is 3 over here, and 1 hours on here. 3 hours on machine A and 1 hours on machine B to produce a bolt. So the profit that he earns by producing these two products, he earns a profit of ₹17 per package. Per one packet he earns 17.50. On nuts, this is on nuts, he makes a profit of ₹17.50 on nuts and ₹7 on bolt. He makes a profit of ₹7, makes a ₹7 profit on bolt, on a package of bolt. And also we are having other information also. He operates his machines A as well as B for at most 12 hours. That means our information is here at most 12 hours. 12 hours. So if we reduce this information in graphical way, it becomes less than equal to 12. That means the machine A used for 12 hours or less than 12 hours. Similarly, this is machine B also used for at most 12 hours. 12 hours. That is less than 12 hours. This is the constraint. So we have to find out the objective function, constraint, and that objective function and constraint are known as formulation of mathematical formulation of graphical representation. Students, I will give you an example. You say, for example, a soap cost rupees 10. A soap costs rupees 10. One soap, a soap costs rupees 10. If two soap, therefore cost of two soap will be, how much it will be? 2 multiplied by 10, that is 20. If if I purchase X number of cost of X soaps, then it will become 10 into X, because a cost of a soap costs rupees 10. Cost of two soap, it will be 2 into 10. Cost of X soap will be X into 10. That will be our formulation. So I will be using this formula over here to formulate all these formulations. So our objective function, what will be our objective function? This will be our objective function. This will be our Z. This will be our Z. So objective function, that is Z equal to, that is on one pocket, on a package of nuts he earns 1750. So if he produce X number of nuts, X number of package of nuts, then how much profit he will get? On one nut package he makes a profit of 17.50, then X number of package, that will be 17.50x plus, and on bolt he will earn 7 rupees on one packet. Y number of packets if he produce, then it will become 7y. This is our objective function. Now we go to the constants, because that we are using two machines, A and machine B, that should be less than 12. That should be less than 12. Constant subject to, this is subject to constraints. Constraints will be, this is for packet of nuts it takes 1 hour for machine A. So if he produce X number of package of nuts, then how many hours? 1x constant, this constant is machine A's constant. Machine A का constant क्या होगा? तो machine A का constant यह होगा कि machine A पे क्या चल रहा है? एक पैकेट नट्स पे 1 घंटा लग रहा है, और एक पैकेट बोल्ट पे 3 घंटा लग रहा है मशीन. वी आर यूजिंग मशीन ए फॉर नट्स एंड बोल्ट. 1 packet of nuts, it takes 1 hour. If we produce X number of packets, then how many time it will take? It will take 1 into X plus 3 hours on a package of bolt. Then if we produce Y number of package bolt, then it will become 3Y. And that time should not be greater than 12. It should be less than 12. This is the machine A constant. Machine A can be used for only maximum for 12 hours or less than 12 hours. Similarly, we can find out the constant of machine B. The constant of machine B, machine B's constant. Machine B's constant. Constant means condition. That can be used only for 12 hours. So I have to multiply 3 by X and 1 by Y. This is 3x plus 1y less than equal to 12. These are the two constants. Now we are having another constant, that is non-negative constants. X and y greater than equal to 0. That means X is the number of package of nuts and Y is the number of package of bolt. So either he will produce nothing or he will produce more than 0. Do you understand? That's why we call it non-negative constant. Non-negative constant. So rest, you see, we have to find out objective function. The objective function is, we have to make it maximize. We have to make this function maximize his profit. We have to find out the maximum profit of this function by using this that you have already done. So I try to solve this inequations. I have to find out the feasible region. So I'll make it in a tabular form. Inequality, equality, intercept form of equation, feasible region. At 0, 0. Feasible region, okay. Intercept form is written as x by a plus y by b equal to 1. I will write it down, x plus 3y less than 12, 3x plus y less than equal to 12, x greater than 0, y greater than 0. This table I have shown you before, so I would like to make it in equation form. X plus 3y equal to 12, 3x plus y equal to 12, x equal to 0, this is y equal to 0. Now I would like to make it in intercept form. That is, if I divide both this side by 12, then I'll get x by 12 plus y by 4 equal to 1. This x by 4 plus y by 12 equal to 1. For this we don't need to make it into intercept form because this is already solved. Now I would like to use this point here in equation first. If I use 0, 0 over here, then this will become 0, 0 less than 12. That is, I have to shade it towards origin. Again, if I use this point 0, 0 in equation, feasible region is obtained by putting this origin point in equation. Then I'll get 3 into 0 plus y equal to 0. That comes 0, 0 less than 12. That means towards origin side. We have to shade it towards origin side. Origin. Now I would like to draw it on a graph. This is x-axis, this is y-axis, this is your 0. So I have to see the coordinate of x, that is runs from 4 to 12. 4 to 12. It should be 2, 4, 6, 8, 10, 12. This is x-axis. Similarly, same fraction. 1, 2, 3, 4, 5, 6 over here. This is 2, 4, 6, 8, 10, 12. Y and the coordinate of y also runs from 4 to 12. So now I will try to find out the intercept of x-axis and y-axis. Intercept of x-axis at 12. Intercept of x-axis at 12. This is one of the point, that is 12, 0. This is 12, 0. And y-axis intercepts at 4. Y-axis is intercepts at 4. That is 0, 4. X equal to 0, y equal to 4. Here x equal to 12. X equal to 12, y equal to 0. Y equal to 0. So I will draw a line that passes through the line 2 points. This line will be the equation of this line. Okay, x plus 3y equal to 12. This is the equation line of this line. It shades towards origin. So this shades towards origin. Origin means 0, 0. If I again tell you this is our origin 0, 0, if you use here, then that will be less than 12. That means our statement is true. 0, 0, 0 plus 0 less than 12. 0 plus 0 is less than 12. That is 0 plus 0 is less than equal to 12. This is 0 less than 12. That's why we shade it towards the origin side. We shade it towards origin. Like this. We have to shade this also, but we are not much interested in, because it make our solution region very difficult to find it out. Although you can shade it. Now I will try to locate try to draw the equation of second line, this line. Okay, 3x plus y. That line is intercept at x-axis at 4, y-axis at 12. X-axis at 4, x-axis at 4, this is our 4. X-axis at 4, y-axis at 12. That means here, somewhere here. So if I join these 2 points, then it becomes another straight line. This is another straight line. This is another straight line. Name of that straight line is 3x plus y. 3x plus y equal to 12. So these two lines are intersected here. We have to find it out, the point. See? And it says that if we use this 0, 0 here, then it will again it will be true. 3 into 0 plus 0, that will become 0, 0 less than 12. That means we have to shade it towards origin. That means towards origin means this way. This is towards origin, because origin is over here, so we have to shade it to in this side. Other side is considered as non-solution region. Now I would like to find out, can you imagine if we shade this line towards origin, this line again towards origin, and solution of this region, you already know that x-axis is greater than 0. That means this is your x-axis. X greater than 0 is y-axis. Greater than 0 means it goes like this. So our portion is this one. This one is our common portion. This one is our x-axis portion. This is the solution region of x-axis. Similarly, y greater than equal to 0. Y equal to 0 is this one. Y equal to 0 is the line this one. And if y is greater than 0, that means it goes upward. The moment of y always goes upward. So I'm getting this portion again. This portion again. I'm getting this portion also, but we have to find out the common shaded region. That is, this will be our common shaded region. This will be our common shaded region. For that we say that feasible region. Feasible region. Feasible region is nothing but common region of all these linear inequations, and it is bounded also. It is bounded. Bounded means you will find maximum and minimum value in this portion. So students, we try to find out the corner points. Corner points, that is origin, and this is 4, 0. This one 4, 0, and this one is 0, 4. 0, 4. This one, and this is the intersection of two lines. That is x equal to. For that, if we are not sure, then we have to solve this two these two equations simultaneously. So we got 3 points, that is 0, 0, 4, 0, and 0, 4. The fourth one we have to find it out with the simultaneous solution. Simultaneous solution. X plus 3y equal to 12. 3x plus y equal to 12. If we, this is your first, this is second equation. If we multiply this by 3, 3x, 3 3 is 9, y, 3 12 is 36. If we subtract it, then minus 3 plus 3 got cancel, minus 9 plus y, minus 8y, this is minus, this is minus 36 plus 12, that comes out minus 24. Then y equal to minus minus cancel, y equal to 8 1 is 8, 8 3 is 24, y equal to 3. We got y equal to 3. Put this value in one of the equations, say here in first. Put y equal to 3 in first, that is x plus 3y equal to 12. X plus 3y equal to 12. If I use y equal to 3 here, 3 3 is 9, it becomes 3 into 3 equal to 12. Then 3 3 is 9, x plus 9 equal to 12, x equal to 12 minus 9 comes out 3. We got x equal to 3 and y equal to 3 over here. This is the intersection of two lines. So we got the third. We use this in the objective function. Maximize, we have to make it whether on which point we are getting the maximum value. If I use 0 0 here, x 0, y 0, then it will become 0 into this, it will become 0. 0 into 7, it will become 0. I got 0 over here. I have 4 at x, 0 at y. Here 0 into 7 plus 4 into this, 0 0 0 7. Decimal at two places. This is 7, this is 70. Okay. Next 0 and 4. 0 into this becomes 0 plus 4 into 7. Y equal to 4. 4 7 is 28. This is 28. And at the last 3. X equal to 3. 3 0 0. 3 5 is 15. 1 carry. 3 7 is 20, 3 7 is 21. 22. 2 carry. 3 1 is 3. This is 5. 52.50 plus 3 7 is 21. It becomes 70. If you add these two, 73.50. So you have to compare the values of these points. So maximum value, this is not the maximum, this is not the maximum, this is not the maximum, this is your maximum value of the function at point this. Means maximum value of function is 73.50 at the point this. If he produce 3 packets of nuts and 3 packets of board, then he maximized his profit by 73.50 rupees. So students, with that I would like to finish my lecture over here.